For decades, the image of a pilot has been one of calm authority. Two figures at the front of a metal tube. Glowing dials, switches, screens. They are the human element in a complex machine. We place our trust in their hands, their training, their judgment. But a new presence is quietly entering this sacred space. This third crew member is not human. It does not wear a uniform. It is artificial intelligence, a silent data-driven partner. This is not science fiction. It is the next chapter in aviation. The co-pilot concept is about redundancy and support, sharing cognitive load. AI fills a similar role, transcending human limits with speed and insight. It processes millions of data points in a fraction of a second and never tires. Its arrival is about augmentation. AI is here to make good pilots even better. Aviation has been a story of progressive automation. The first major leap was the autopilot. It could hold a course and altitude, freeing pilots from constant inputs. Modern systems execute pre-programmed flight plans from takeoff to approach. Powerful tools, yet fundamentally rigid. They follow orders, they do not think. The line between automation and true AI is the ability to learn and adapt. Traditional autopilot is if-then. AI ingests data, detects patterns, predicts. It learns fleet-wide performance to advise optimal climb profiles. The evolution moves from doing to advising, a new tool category on the flight deck. Think of a spectrum: heading hold, advanced FMS, then AI. Airlines start with low-risk advisory apps. Fuel planning on a tablet. Proven logic is layered onto existing systems, step by step. It is a marathon of building trust, one function at a time. Modern aircraft are flying data centers, generating terabytes every flight. Thousands of sensors monitor temperature, pressure, and surface positions. AI shifts reactive maintenance to predictive, sifting real-time streams for faint signals. A tiny vibration becomes a clear signature match to past failures. The system flags an inspection and lines up the replacement part at arrival. Unscheduled repairs become planned, fewer delays, more reliability. For pilots, it means confidence in the machine they fly. AI also boosts situational awareness, fusing radar, satellite, reports, infrared. Hazards are clearly highlighted. Storms boxed, bird activity marked. Sea turbulence 20 minutes out with a minimal fuel deviation. In low visibility, a synthetic view shows the runway precisely. It is not about the AI flying, it is about clearer eyes for the pilot. Every flight begins with a plan, balancing weight, weather, winds, ATC, fuel. Traditionally safe and workable, not always optimal. AI analyzes millions of possible routes in seconds to find the true optimum. Perhaps a longer path at higher altitude saves more fuel via stronger tailwinds. A 1 to 2% fuel reduction scales to millions and lower emissions. But plans change. Weather shifts, airspace fills, runways close. AI instantly presents options: arrival time, fuel use, passenger comfort. Scaled system-wide routes deconflict and streams smooth. Small speed adjustments prevent holds and cut delays. This is orchestrated efficiency, not just a single flight optimized. Pilots remain in command, choosing the best among good options. The result? Calmer rides, better time and fuel performance. Air travel is safe because of redundancy and rigorous training. In rare emergencies, time is critical and stress is immense. AI rapidly analyzes cascades of warnings, pinpoints root causes. It pulls the exact checklist and highlights next steps. Imagine an engine fire. Alarms blare, lights flash, the AI guides. It confirms actions, flags misses, and monitors systems. It computes new altitudes, speed, range, and diversion options. It can prep communications, freeing pilots to fly and decide. AI builds a protective awareness bubble, spotting subtle threats. Unidentified drone, 2 o'clock, 500 feet below, suggests 10-degree right. A calm guardian in the machine, another layer of protection. Helping crews avoid danger before it becomes critical. Technology only works if people use it. Trust is the key. Trust builds slowly, one good advisory at a time, and can vanish with one bad call. Opaque recommendations breed skepticism. Pilots need the why. Suggest climb to 37,000 FT to save 150 kilograms of fuel by capturing jet stream. Training is where trust is forged long before passenger flights. Pilots practice when to follow and when to override. Repeated reliability across hundreds of runs builds confidence. Early AI tools advise, pilots retain full authority. As hours accrue, tools integrate naturally into workflows. Pilots see fuel savings, smoother rides, reduced load. The goal isn't blind trust, but well-founded confidence. A true partnership formed by rigorous proof. No technology enters the cockpit without rigorous certification. FAA, EASA. Traditional processes assume the same input yields the same output. AI is different. Validation and verification must prove safety under all conceivable conditions. Start with advisory, non-critical roles. Scale scrutiny as capability grows. Low-risk applications build data. Pilot remains the final decision maker. Stakeholders gather performance evidence in controlled environments. Explainability and traceable decision paths become mandatory. Millions of simulated hours, real-world tests, and rare edge cases included. If an incident occurs, who is responsible? Pilot, airline, manufacturer. New legal principles are being drafted for autonomous systems. Clear accountability builds public and professional trust. The rules are being rewritten carefully, deliberately. As aircraft become more connected, they also become more vulnerable. Connectivity powers AI with real-time information for smart decisions. Every link is a doorway. Attacks can poison data or spoof inputs. Critical systems are isolated, but AI uses cross-domain links that must be secured. Defense is multi-layered. Segmentation, strong encryption, continuous monitoring. Teams of cybersecurity experts probe for weaknesses before attackers do. AI is only as good as its data. Clean, accurate, secure datasets are essential. Strict access, auditing, and governance protect the learning pipeline. Train in protected environments, build a digital fortress around the AI. Pilots must trust that recommendations are untampered and verified. Security must be built in from day one, not bolted on. Safety today includes cybersecurity end-to-end. AI won't make pilots obsolete, but it will change their job, from hands-on manipulation to high-level systems management. Focus shifts from micromanaging trajectory to managing mission, safety, and efficiency. Training adapts, manual skills remain, tech literacy grows. Pilots must understand capabilities and limitations. A key skill, knowing when to trust and when to question. The pilot remains the arbiter, applying judgment, experience, ethics. Train with the AI and without it. So, dependence never forms. AI can't calm a nervous cabin or lead a crew mid-diversion. It can compute risk, but not make complex ethical calls. Pilots become conductors of a complex orchestra of systems. Their job isn't disappearing, it's elevating. AI in the cockpit is not a takeover, it's a partnership. Combine computational speed and encyclopedic knowledge with human judgment, adaptability, and ethics. Safer, more efficient, more sustainable flight. AI already reduces fuel consumption, cutting costs and emissions. Predictive maintenance reduces delays and prevents incidents. Enhanced awareness buys time. Time saves lives. Expect smoother flights, more direct routes, higher safety. Move deliberately, test, validate, explain, and train. Transparency keeps pilots, regulators, and the public aligned. Machines handle the math, humans lead, manage, make the final call. Together, human and machine will keep flying forward.